Alright, this last section is on something called Graham's Law. And Graham's Law, right here, states that the rate of effusion, that can actually work for diffusion also, the spreading out of a gas, but it varies inversely with the square root of the molar mass. In other words, it just talks about how fast gases go. And the gist is, the lighter a gas, the faster it's going to be, just simply because it's a lighter gas. So here's what we're going to do. Let me go through a couple examples here on this this Graham's Law worksheet. The first thing we're going to do is get the formulas. So let's look at number one. Formulas: hydrogen. Hydrogen is diatomic, so we're going to write H2 for hydrogen. Chlorine gas. Again, chlorine is in that cluster where it is also diatomic, and those diatomics again form a number 7 on the periodic table. So when we look at the periodic table, if they are diatomic, they start right here. So N, when it's by itself, is N2, O2, F2, and so forth down this way, all the way to I. So they form a number 7 if they are in fact diatomic. And then also hydrogen, which is way over here on the periodic table, is also diatomic. Nothing else. So nothing in this particular column is diatomic. If I say neon, it is just Ne. It is not Ne2. So diatomic are those right here on the periodic table. Okay, so we have their formulas. Now I'm going to write their molar masses underneath this. So I'm going to find the molar mass of hydrogen. And because there are 2 of them, the molar mass is 2.02 grams per mole. Same thing for chlorine. We're looking at 2 decimal places, so 1 chlorine is 35.45. If there are 2, we just multiply that by 2, so 70.90. That's the first step. Get the formulas and get the molar masses. Second step, we're going to do the calculations. Now here's how we're going to do the calculations. The Graham's Law is inversely proportional to the square root of the molar mass. So for step number 2, we're always going to put the biggest molar mass on top. So we're going to compare these 2 molar masses. We're going to put the biggest one on top. And we're going to write it something like this. 70.90 goes up here. The units are grams per mole. We're going to divide that by the molar mass of hydrogen. Again, the biggest one on top, smallest one will always go on the bottom. And we're going to get a numerical answer for that. So 70.9 divided by 2.02, and then the square root. And we'll just do 3 sig figs because this has 3 sig figs. So 5.92. Now the grams per mole cancel out, and so this is just a numerical value, which brings us to step number 3, the statement. Blank effuses blank times faster than blank. Okay, when we look at effusion or diffusion, the fastest gas is always the smallest gas. So this one right here is faster, and we know that because hydrogen is only 2 grams per mole, whereas chlorine is 70 grams per mole. So hydrogen is faster, and we know that just simply because it is smaller. So for step 3, we'll just write that over here. We're going to say H2 effuses blank times faster than Cl2. How many times faster? That's what this calculation right here tells us. So hydrogen will spread out almost 6 times faster than chlorine. So if I have those 2 gases and they were racing each other, this one would win by a long shot just simply because it has a smaller molar mass. All right, I'll do one more example, just kind of give you the gist again. Let's look at number 2. We got oxygen, argon. So we're going to write the formula for each. Oxygen is diatomic, O2, and then we're going to get the molar mass for that. Oxygen by itself is 16. If there are 2 of them, the molar mass is 32. Versus argon. Argon is not diatomic, it's a noble gas, and none of those are diatomic by nature. So argon is just Ar, and get its molar mass. Step 2. Whenever we do step 2, for the calculations, remember to always put the larger number on top and the smaller number on bottom. Same thing here. So, larger number, you're comparing these two gases, you put the largest one on top, 39.95, and we're going to put the smaller one on the bottom. So with Graham's law, all we're doing is comparing the molar masses of those gas. So divide, and make sure you take the square root after you divide. And again, since the units cancel out, the grams per mole in this case, this is just a numerical value. Just a numerical value. So for our statement, which one's going to effuse faster? Remember, it's always the lighter gas. That is the one that has the less mass. This one is faster. So my statement looks like this. Oxygen is going to effuse blank times faster. Well, in this case, it's 1.117 times faster than the other gas, which in our case is argon. So lighter gases are faster than heavier gases. It's all based on molar mass. But there's your Graham's law calculation, and that's really all there is to Graham's law.